All right. Hello, everyone. My name is Venus Izadi. I'm a solution architect at Red Hat, and today I want to talk about Red Hat OpenShift for Windows containers and how you can technically modernize your Windows workload using OpenShift. We'll talk about all the different ways, and we will have a demo as well. All right, so before we move forward, let me bring up this. Great. So today we want to talk about a little bit about what Windows containers are and why they're so important and kind of benefits you can get from them. The technical overview of Red Hat OpenShift, very high level, and how you can kind of deploy your Windows workloads on OpenShift. I try to keep them not too long. It would be, I don't know, like a 10 minutes presentation, very short. The demo would be a short demo, consists of two sections. The first one, I already deployed an application, a mix of Windows and it would be in different ways. So we are going to talk about it in more details, but different ways that you can have your workloads in OpenShift. And in the second step, I will show you how easy it is to actually deploy this workload. Feel free to, if you have any questions, to add any comments or contact us if you have any concerns or questions, and we will come back to you as soon as possible. Great. So let's talk about Windows containers and why they're so important. All right, so we all know that there are lots of Windows servers out there. There are lots of Windows applications that they want to move to the cloud native deployments, like moving from traditional to the cloud way. And this transition from data centers to cloud, it needs to have, like, we need to support technology for this movement from traditional data centers to move them to the cloud. To avoid to rebuild all these workloads and kind of make it like start developing your application from scratch, we can use some technologies like containers. And you may actually know about containers. I'm not going to go through the details of what containers are, but the Windows containers are important because there are so many Windows applications out there, and moving them to the cloud, the first step would be containerizing your applications. And as a result, you will need some container orchestration tools like Kubernetes and OpenShift, which is on top of Kubernetes. The benefits of Windows containers, you can summarize them in kind of 3 different words for portability, agility, security, and cost reduction. Technically, if you're using containers, you will have lots of opportunities to accelerate the adoption to the cloud, of course. You will have more control over your workload. It gives you more portability and agility for your workload. And it's because you don't actually need to virtualize your hardware and take multiple full stack of software from applications to operating system and everything. So you don't need to do all of that. All you need to do is use containers and put that on top of a single Windows operating system, and then you can move it anywhere you want. You can put them on public cloud or private cloud or on OpenShift on premise, wherever you want to do, whatever you want to do, you can do that with the containers. And they will reduce the infrastructure and management costs for your Windows applications because they're small and lightweight, and you can move them easily across bare metal systems or different environments, public, private, hybrid cloud, or even edge environment. It depends on you. And all right, so we understand containers are important and beneficial, but why OpenShift? Why Red Hat OpenShift for your Windows containers? We will have a better understanding of this when we are doing the demo. You will have a better understanding when you see these processes, but to give you a very high level idea, you can move your Windows containers to OpenShift without needing to completely re-architect or write new code. So imagine you have some legacy workload and you're not planning to upgrade them to the latest version. You can still use containers. You can still put them on OpenShift and take advantage of all Kubernetes benefits or all the stuff that is in new development of cloud development stuff. So you don't need to re-architect your whole applications anymore. It will help you to lower your deployment costs for containerized workloads, and it will improve the productivity and DevOps agility. In the demo, you'll see the interactions of developers and operation teams with the OpenShift tool, and you see how easy for both of these people to both of these teams to work with this tool. And OpenShift will help you to increase the portability and availability of your application across hybrid cloud environment. So you can have different environments like bare metal, or you want to have part of your application on the cloud or on edge. If you have edge installations, you can easily move your applications along these environments. All right, so this is a very high-level architecture of OpenShift. I'm not going to go through all of these details. I will leave it to you to go through all the details, but I would like to highlight a few items here which are very important. First of all, on the lowest layer, you can see that you can have OpenShift on different environment, on your bare metal, physical, on your virtual environment, your private cloud, public cloud, and the last one would be the managed cloud. That's the part I want to talk about a little bit more details. So when we're talking about managed services or managed cloud, we are talking about this. Imagine this is like OpenShift. Sometimes we can have OpenShift on top of like AWS, and it would be managed separately. But this new offering, Red Hat and AWS, or like different cloud services, of course, I'm using AWS just as an example. We have this offering as ROSA, Red Hat OpenShift service on AWS. It means that Red Hat and AWS would have a jointly supported service for you to run your workload. So all you need to do is just thinking about your workload. You don't need to take care of anything about your infrastructure anymore. So if this is your infrastructure underneath, you don't need to take care of that. Red Hat and AWS jointly will support you with that. All you need to do is taking care of your workload. We have the same offering for Azure. It would be Red Hat and Azure, which we call that ARO. The same offering for other cloud providers as well. Just to give you an idea, I just wanted to mention that these Red Hat managed services offerings are out there, and they can really help you with just focusing on your workloads. All right, so that was just a quick note about OpenShift can run on different environments. Now, if you take a look at these blue boxes, platform services, application services, and developer services, these are just the different services that OpenShift will provide to help all the people using OpenShift to be more productive and have a better DevOps agility and workflow. For example, you will see the CI/CD pipelines. There will be a built-in CI/CD pipeline in OpenShift. Like so many different services, these are just examples of it. OpenShift supports different languages, so many different languages and databases. And for developers, there are like built-in IDE for them, which I will show them in action in demo time. All right, let's talk about some use cases for Windows containers workload on OpenShift. But before that, I want to do a little bit of whiteboarding here. So There are different ways that you can think of modernizing your application in general. This is kind of famous for being 6R by Gartner reviews. They call it because it all started with R, and there are 6 of them. 6 ways of thinking of modernizing your application or considering modernizing your application. The first one would be retiring. It means that, well, you don't need to do anything about that. Your application is going to die sometime soon. Retain means that your application is going to die sometime in the future, so you don't want to touch it at the moment. It's working, it will die in the future. Just retain it for now. So you don't need to do anything, you just keep it as is. Rehosting your application. It means that you're migrating your application as is to a new platform. So if this is your old platform, you will put it in a platform. This, as an example, you're migrating your virtual machine as is to a new virtual platform. You're like using, I don't know, something like VMware, and now you want to use them on OpenShift virtual machines. OpenShift virtualization. All right, so the other way would be re-platforming your application. It means that you are changing the platform and you are making some optimization in your applications. You're not going through the whole re-architecture and stuff or significant code change, but you're optimizing your application to get more benefits out of this new platforming. As an example, we can say containers. For example, you are moving your application into a container so you can move them into the cloud. Refactoring means you're changing how your application is developed or re-architected. I mean, you're changing the way that your application is developed or architected. You're typically doing that to be more cloud native. As an example of that, you're changing this monolith application into microservices design, and you're changing it you put it in the cloud. So it needs the whole change of code and refactoring and everything. Like you're changing the whole monolith into the microservices. And repurchase means you're moving to SaaS or replacing portion of your application with a SaaS service. For example, you're taking this service out of your application and you give it to the SaaS offering, for example. And it would be easier. For example, this can be you're using, I don't know, Kafka as a service. So these are different ways that you can think of modernizing your applications. I mentioned them because these, like the same as we talked about, these are different ways that you can modernize your Windows applications as well. The same concepts. We didn't mention the first two, retire and retain. But let's talk about specifically Windows applications on OpenShift. How can we modernize our Windows application on OpenShift? Different ways. The first way, Red Hat OpenShift virtualization. We just talked about rehosting. That means that you are rehosting your existing virtual machine. All you need to do, imagine you have this virtual machine, you just lift and shift it and just put it on OpenShift virtualization. You don't need to do lots of changes. Sometimes we actually, no changes required as well. So all you need to do is just put them on the OpenShift virtualization. As simple as that. All right, so that's way number one. Way number two, second way, is using Linux nodes. I color it as red because this is the recommended way for everyone from Red Hat. And I mark it as Linux nodes or red nodes, which has CoreOS operating system on it. All right, so it means that if you have .NET Core containers, it means that if you have .NET applications version 5 or anything higher, you can run them on Linux nodes. Or if you have any Linux containers. So your Windows workload can be on the same node with any other Linux workload. They can communicate with each other, interact with each other. And it would be very simple to work with because OpenShift would handle everything about this node. It will manage it for you if there's any updates or if any security patches, for example, for this operating system. OpenShift will do everything, manage everything for you. As I mentioned, this would be the recommended way to use nodes for OpenShift. All right, the third option is using the Windows nodes. Windows nodes has Microsoft Windows operating system on them, and you can run typically any workload, any .NET workload on them. Means that if you have traditional workload, if there is any .NET workload 3.5 or higher, can run on these nodes. As I said, like .NET Core is version 5 or higher, and traditional framework containers would be 3.5 or anything higher than that. And the fourth option is bringing your own host instance, which is used for the time that you have some Windows servers in your data center that you regularly update, patch, and manage yourself, and you just want to lift and shift it from your on-premise to cloud. So you just want to lift and shift your on-premise workload to the cloud-native world, and you already have the Windows server on your data center. You can just lift and shift your server and put it on OpenShift. It will be on the Windows nodes, and yeah, like easy as that. But we usually say that because you need to manage the node yourself, that would be something. For example, if there is any updates for this operating system, or there is anything related for, I don't know, the security patches for this operating system, you will be responsible for these updates yourself. That's why we usually say if you're using this approach, make sure that you don't have lots of them. Like, don't bring like 100 servers here. Try to have something small, like 1 or 2. Because it would be very hard, or I'm not. This number is not necessarily 1 or 2. We're saying keep it low, so you'll be able to manage them. So these are different ways that you can modernize your Windows application. To summarize, if you have .NET Core, which means that you have .NET applications with version 5 or anything higher, you can use both Windows node and Linux nodes, and you can containerize your application easily and just put them on OpenShift using Windows nodes or Linux nodes. But if you have .NET Framework, which means that it's more legacy code, if it's anything above 3.5, you can use on the Windows nodes, or if it's anything lower than that, 3.5, we highly recommend you to just upgrade it to .NET Core. It's not even supported anymore, but we just ask you to upgrade it to .NET Core, and then you can run it on Linux nodes or Windows nodes. All right, so I hope everything makes sense to you so far. We are going to show a demo. I think you'll have a better understanding of everything after you see how everything works in action. The demo section today, it has actually 2 sections. The first section, I already deployed this application because it was a little bit heavy. It was like 5 gigabytes. That's why I already pulled the container and just deployed everything already. But in the second section, I will show you how to deploy a sample application, and we will go through all the steps and show you how easy it is. But the first one, that this application that I already deployed for you, you see that the front end part of this application is sitting on the Windows node, and the backend and the database are sitting on the Linux node. And you see how easily they're interacting with each other. You wouldn't even notice if I wouldn't tell you that it's a Microsoft Windows node. You wouldn't even notice that in the visual part. All right, so that's our demo in a nutshell. Let's go through the demo part. All right, so this is OpenShift console, if you haven't seen it before. Going briefly, just want to explain how does it look like OpenShift, and then I will show you the application. So OpenShift consists of two different perspectives, admin section and developer section. It's designed for two different teams. So admin is for operation team, everything they need to do to manage this cluster, they can do it on this part. For example, they can get an overview of the whole cluster, plus the cluster ID. The provider is AWS. It means that this OpenShift is sitting on top of AWS. It would be exactly the same if it was Azure or Google Cloud or somewhere else, or even on bare metal or any other cloud providers. You see all the details about your clusters. If as an admin or as an operation team you would like to upgrade this cluster, you can easily come here, select the version. It would be the recommended version is like 4.10.47 at the moment. You can just click update and it will quickly upgrade your cluster with no hassle. So technically everything you need to do as an admin, if you are working in operation team, you can come here and work and manage that networking, everything that you can think of. The part that I want to show you a little bit more details would be the operator hub, which means that it includes all the operators. Operators are kind of plugins for your OpenShift cluster. It means that you can add them to your cluster and extend the capabilities of your cluster. For example, imagine you are working with GitLab CI/CD, for example. You can just come here, install the GitLab runner, and work with the GitLab CI/CD, and just inject it here in OpenShift and integrate it with OpenShift. So there's no conflict. We have so many partners creating operators for OpenShift. So just come here, search for your operator, and it will be most likely you can see that here. Other examples could be advanced cluster security for your Kubernetes, which is the time that you want to lift your security to shift your security to left and have security as part of your pipeline, for example, to create DevSecOps. So you can see by these concepts, having operation team, developers, bringing security into the play for pipelines, you can have a proper workflow for DevSecOps. All right. These are the installed operators that I already installed on this cluster. You can see we have dev spaces, pipelines, and Windows machine config operator. In the demo later on, I will show you what pipelines and dev spaces are. But for now, just wanted to highlight that Windows machine config operator is an operator that you install to bring Windows nodes into your cluster. Actually, for getting more details, let me open it here. Sorry, not this one. Yeah, actually, it's this one. I already installed it. Anyway, so it will give you all the information and the details you may need for using this operator. All right, so that's that. And we move on to the developer perspective, which is for developers, of course. I'm going to choose this Net Candy Store project. That's the project I already created, and I deployed some applications, the one that we just talked about, that has having a front end, back end, and database. Again, later on, I will show you how to deploy an application in different ways. But for now, I just want to show you how everything would look like. This is the front end part of the application, Net Candy Store. Get categories is the back end part, and MS SQL is the database. You can think of it as this visual part can be very helpful for developers. Imagine you have lots of components and microservices that are interacting with each other. This visual part can be very helpful for developers. The front end part, we can get all this information about the pod. For example, the labels, the namespace, or all the details of the pod in here. You can get the services or routes of this, which means that this is the URL for this application. So if I click on this little URL, it will open the application for me. What I was trying to say for routes is that expose this URL to outside world, so you can see, you can access it anywhere, like any other routes. You can interact with this application. I'm not gonna go through that, but just want to say, like, this is a working application, and you can open that by easily clicking this open URL icon. So you will see all this information about the pod here for all of them. The part I wanted to show you is, first of all, I want to confirm that this is a Windows pod. So there are two ways. The little bit more complicated one is using the terminal. I'm going to get all the nodes with the label of Windows, and it will show me that. One of the nodes with this Windows, it had like operating system would be Windows for that, and I want to see what version of Windows is installed on it, and as you can see here, it's Windows Server 2019. So I'm not gonna work with this terminal too much. I just want to show you that you can interact with your OpenShift cluster with your terminal as well, and it gives you, of course, like more flexibility of doing stuff. But another way which developers would love would be coming to this pod and even access to the terminal from here. Easy. You can see it's Microsoft Windows. You can get all the logs, the YAML file, all the metrics, all the details for this pod. It would be the same for all the pods. So if I come to the resources, click on the pods, I can access the terminal. And as you can see, this is a different terminal. So each pod, you can easily access to their terminal. It is important for developers because, you know, containers, if you know containers and work with them, you know that they can get reset and they can change their IP, and every time you want to access that inside the container, you need to get the IP address and just go inside. It would be a lot easier to do that visually with just accessing the terminal from the UI. All right, now that you have a little bit better understanding about what everything looks like, I would like to also say I can easily scale up and scale down your pods by clicking this little icon. It will show you that now it's scaling to 2. And you can see the container is creating. It will create another pod for you, another container, and now there are 2 containers supporting your backend. So if you have a heavy workload, for example, on the weekend, you can easily scale it up. There are other ways to do the scale up and scale down automatically, of course. This is just a manual way of doing that for demo purposes. And you can see logs as well in case you need to. All right, so, and that's that. And you can, of course, add health check for your pod, saying that, for example, if anything goes wrong with this pod, notify me or do something about that. These are all the ways you can do to make sure your application is running and it's running correctly and in a healthy way. All right, so I will leave this part for now. We go for the second section of this demo, which is deploying a new .NET application, because I want to show you how easy it is to actually work with that. I'm going to create a new project called Demo VNS1. Yeah. And as you can see, there is nothing deployed to this project yet. I'm going to click add, and it gives me all the options, all the different ways I can bring some applications into this project. All right. There are different ways. The way I deployed the previous application was Helm charts. I used Helm charts to just deploy that. There are different ways, easier ways, of course, and you can just get your URL, git URL, and deploy the application to cluster. So one of the very powerful points for OpenShift is an approach called S2I, or source to image. It means that you can containerize your application even if you don't have a Docker file or anything. If you have a git URL, OpenShift can help you to wrap your application around a container and have a base image and wrap everything together as a container and push that into OpenShift. So all you need to do is have a source code. It will take the source code and it will convert it to the image. Or if you have the URL for your image in an image repository, you can just give us the image URL and that's it. All right, so another way that I would like to talk about is a catalog, developer catalog, which means that it gives you a base image and you just give it a URL, your source URL, and it will create from the source, it will create a container for you and help you to deploy it to the OpenShift. For example, look at this .NET application. It says that it will build and run on .NET 6, and there will be a UBI 8 for this. You will have a .NET 6 application, and it will put it on top of the UBI 8, and it will wrap everything in a container, and voila, your application would be containerized. All right, so you can have your git URL here, but I'm going to use a sample URL for now. You can give it an application. I will just call it VNS for now. I'll leave all this stuff as default, but of course you can change them if you want. This pipeline, if you remember, I added an operator called pipelines, Red Hat pipelines. I'm going to add a pipeline just as a sample pipeline to show you how easy it is to work with the pipelines. It will create a very basic fetch repository, it will clone the repo, it will build it, and it will deploy it to OpenShift. I will leave everything else as default. I'm not going to add any health check or scaling or resource limit for now, but bear in mind that you can do that if you want to. Click create, and it's going to create this .NET application for us shortly. I clicked on it. So at the moment, I mean, it says image pull error, but what is it doing at the moment, because it's still in the process, it's going through the pipeline, because I added a pipeline for that, if you remember that. So this is the pipeline I added. Of course, if you want, you can just edit that. I mean, I'm not going to do that right now because it's in the middle of running the pipeline, but it's very easy. You just add some tasks. There are some tasks that you can choose from, some predefined tasks. You can do that in parallel. You can do that so many different ways. You can define your pipeline. You can do that visually, and it will give you the YAML version of it as well. So you can have the YAML file of it if you want to. And you can define the parameters for your pipeline, which gives you lots of flexibility and reusability for your pipeline. It means that you can define one pipeline, for example, for your whole microservice, all the microservices applications that you have, and it will take it different parameters and it will push everything into the OpenShift. I'm going to cancel this for now. Let's go back, not here on the pipeline section. So this was a pipeline we defined. This is the pipeline run, which means that it injects all those parameters into the pipeline and it's actually running it. I can click on here and see all the logs and details of it. As you can see, it has different steps. And after, if everything goes correctly, it will deploy the application to OpenShift. Again, like the powerful, OpenShift pipelines can be very powerful because of the reusability part of it as well. So you just define one thing and you can reuse it for your front end or back end or any kind of applications that you want to. All right, so let's wait for this last step to finish, and then if we come back to topology, you can see that it changed to the dark blue. It means that it's deployed and it's running. It means that if I click on this little icon, open URL, I should be able to see a sample website. And that's correct. We see that. All right, so, and this part is still showing the pipeline. The last part is still running. Let's go and see the logs. I think it's doing in the background, but it should finish very shortly. And then you, in topology, instead of this running icon, you will see a tick saying it's been deployed successfully. And all the configuration, here we go. Everything is finished, nice, it's running, and all the triggers has been set up and everything that in a sample application we define. All right, so there is another thing. If you remember, we added an operator called OpenShift Dev Spaces, which I told you that it's IDE that you can kind of use for updating your codes. Yes, I click on that and it opens the IDE for me. It takes a little bit, it takes a few minutes for, or maybe a little bit less, to start this workspace. But I wanted to show you that you will have a kind of IDE. It would be the same as VS Code, but you will have it in a cloud native way. You will be able to open it in the browser. Imagine how easy it would be for new people to get on board. It can be set up based on the all these criteria that your organization is setting it up for you. So no more VDI or anything else for you. And as we mentioned before, you can just go through this pod, scale it up or down if you want to, and observe. You can see all this CPU usage for it at the moment, and this part, that's it for now. Still waiting for this to start. And while we're waiting, I'm going through my notes, making sure I cover everything. Yeah, so one more thing that I want to mention for the pipelines. You can add triggers to your pipeline, which means that come here, add a trigger, which means that if you have any kind of commits or anyone push anything to this repo, it will trigger this trigger and it will run the pipeline for you. So it means that if someone comes here, just imagine this is the code, by the way. This is the sample code that we just used. Imagine that a developer can come on the browser and have some changes. Can easily come here, commit the changes. I'm not gonna commit commit it right now, but if I commit, it will trigger the pipeline. It will run the pipeline one more time, and at the end of that, it will update this pod for me here. So that's the end-to-end process for the user. One more thing about config map and secrets in OpenShift. There are two concepts of config maps and secrets. Config maps are it's a key value pair that you add to your pod at runtime, and that would be the way that you abstract environment variables from the workloads. And secrets are the same as config maps, but used for passwords. It's technically the same concept, but it's only used for passwords. I can inject a secret for my pod, so I can create a config map or secrets and just inject it to my the running pod. I think I covered everything. I want to highlight one more time that these IDEs can have lots of other plugins. You can work it exactly like VS Code or any other IDE that you want to. It gives you the flexibility of just working on your application and not thinking about containerizing your application. Or technically, developers who are working like this, they don't even need to understand how the containerization would work or how the Kubernetes would work. Everything would be handled in the background by OpenShift. They just update or change the code and just focus on developing their applications. They can commit their changes that will trigger the pipeline. It will run the pipeline. If it will succeed, it will update the pod and update the application for you. All right, so that's pretty much it. That's all I wanted to talk about today. Feel free to add comments or contact us if you have any questions. Just a few more links for your own reference. There is this URL you can go to try OpenShift for free. There are some materials that it will kind of workshops that it will walk you through some OpenShift activities. It will be very fun. I would recommend you to try it. There is OpenShift support for Windows containers or release node, which you can go and get some updates about some release nodes for OpenShift supporting Windows containers. And Poly Plus, which if you are a developer getting stuck in legacy code, this will help you to get out of that and use the new features of .NET, which is a very interesting, which I just realized I forgot the link, but I will share it. I mean, just if you search for that, you'll find out. But yeah, so that's pretty much it. There are other ways that we can help you. Feel free to contact us if we can help you with anything. And thank you.